So now we will go through that APB protocol. Okay, this is the design code. Okay, what is the design code you are seeing here? Module APB. So APB is your module name, and these are the input output signals in your module. APB clock signal, P clock, and then reset, active low reset signal, address bus, that is a 32-bit, and W write data is a 32-bit, and then read data bus is a output pin. Okay, because slave is generating the read data, and then write p write signal, write control signal. If it is 1 means doing the write operation, if it is 0 means doing the read operation. And p enable signal, that means your access, you are entering into the access phase or not, this signal will tells you. And p ready signal, this is also output signal, p ready signal. Okay, then it is also generated by slave. Okay, so slave, whenever the slave is ready to receive the transaction, then ready for transfer. Okay, so then p slave ready signal will be there. And protect signal, this protection control is used for actually we are using for privileged access, secured access, non-privileged access. For that purpose we are using protect signal, but here not used. And then right strobe signal, this is right strobe. Right strobe, so here also not used, but basically why we are using the strobe signal means which data bits are valid. Okay, so in right you are doing the right operation, so you are doing some 10 bytes of data you are doing. In that, how many bytes of data is valid, it will tell you. Okay, right strobe signal. Slave error is used by the slave. Okay, that is also output. Whenever you are reaching the output signal, last completion of your output signal, then slave error should be high. And then during the read of write operation, you are putting the slave error means it is not considered. Okay, select signal, which slave we want to communicate it, this select signal will tell you. And then memory write operation, how many locations are there? 10 locations are there. Each location, how much bit we can store? 32 bit each. Okay, so the memory location is 10 location and each are 32 bit. Okay, why we are using this I here? To initialize the for loop variable, loop variables, we can initialize that. So based on this integer I we can use to initialize your loop variables. Okay, so this is the sequential block, say handles reset and write operations. So reset condition as well as write operation also it is doing that. So this is the negative reset time, right? So if it is 0 means, okay, so then I'm getting the reset value. Then it is operating in reset condition, then all the memory values should be initialized to 0. So all the memory locations we are initializing to 0. And then if it is not true, else condition we are running. So that means if it is not getting the reset value 0, and it is if it got 1 means your loop will be failed, and then again else condition we can take that. So during write operation, what we need to keep high, P write signal should be high, and then P address should be valid. And here 10 locations we are taking, that's why I am taking the P address less than 10. And again P select signal should be high and P enable signal should be high. So both signals are high means then only my transaction will be happening. And then see, once this happen means whatever the PW data we are having, that P address, memory of P address we are storing here. Okay, based on the address we are getting the data. See, writing the data into your memory locations. Okay, and again, so what it handles, this is the combination block, handles the read, ready and error signals. Okay, initialize it. So always count begin during initial condition, all are signal are ready signal, that means PR data ready slave error, all signals are 0 here. Okay, default condition that is 0. If you get P select should be 1 and P enable should be 1, then we are in access phase. During that access phase, slave is ready, then ready signal should be 1. Whenever you are doing reading operation, your slave should be in ready condition. Then I am taking the P address condition, P address is also less than 10. If not P write, that means P write is 1 here. Okay, 1 means, so it is not doing here. So if it is 0 means p write is not doing, then write read operation it is doing that. I told you that initially write equal to 1 means we are doing the write operation. 0 means reading operation we are doing. So if we are doing 0 here, 0 bar means 1. Then condition true. Then I am getting the whatever the write data we are having memory address, right? From that we are getting the data into the PR data. Okay, that is the output signal. If you are not getting the read data, then I am getting the slave error. Clear? Just do read and write operations here. Okay, nothing else. Understood? So based on that, we are writing the test bench for this. What are the test bench signals we need to write here? First, we need to import the package. Import all, take UVM import. So import UVM package, scope resolution start. That means importing all the package definitions. And then tick include UVM macros dot SPH. That means all standard macros. So what we are tick include, tick UVM component utils, tick UVM utils we are using, right? Tick UVM utils, tick UVM object utils, tick UVM component utils we are using. So those all macros are including in your top module. Okay, and then so these two lines are common. If you are writing individual components, you can take these components individually for each and every component. And then interface, your interface name. My interface name is app interface. Okay, so app interface I am considering here. Input clock signal, and then input logic reset time. Okay, if you are considering reset time here, okay, so that signal should be mentioned. And then uh, after that, app address signal, all the signals we need to mention here. App address signal, and then write data, read data, strobe signal. So in test bench, all in interface, all the input output signals we need to mention here. Okay, so please select, P enable, please lever, all the signals we need to mention here. After the ending interface, I am writing the sequence item. Okay, during sequence item, what are the inputs are there? P address, PW data, P write, P stroke, P protect. All are randomized here. Okay, what is the output signal? Capturing the read data from the DUT, right? So PR data, P enable is also we are giving as a captured enable value, P select and P slaver. These are all one bit devices. P select is one bit device. There is no need to randomize here. P enable is also one bit device. P slaver is also one bit. P ready is an output, right? So no need to randomize here. P slaver is also output, right? So that's why there no need to randomize. And why we are not randomizing P select and P enable means both are one bit storage devices. After that, I need to register each field macro. See, being a field automation for factory and print, copy, compare. So if you are doing the registration here means it will do that print, copy, clone, compare all methods. So we are doing here. And then tick UVM field int. What is your field name? P address and UVM all on. Similarly, PW data, P write, P store, P protect, PR data, and then P enable, all signals we need to register for this. So registering P address fields with UVM automation. So then we can UVM test bench automatically get that all values here. Custom constructor, and then custom after that custom constructor, just function new string name. What is your component class name? App transaction, and then this is the constructor for transaction object. And then I'm calling the parents by super.new name. So calling the parent constructor here. End function, that is construction is ending, and the class your sequence item class is transaction class is ending. Similarly, I am writing the sequence. Okay, UVM sequence is the base sequence. Okay, from that I am getting the APP sequence here. Okay, So APB sequence, and APB sequence is my class name. Tick UVM object details macros registration with UVM factory. Okay, this is the registration with UVM factory and custom constructor. So I'm creating the custom constructor for sequence and then calling the parent class and in class. So this is the basic thing, and then task body method we are implementing all the transactions. The main sequence body that creates your transaction. Okay, what is the transaction I'm creating here? See, first test case valid writes. Okay, so here I want to print the valid write signals here. Okay, so this is the dollar display is for valid writes, means just printing the valid writes. That is the display purpose we are writing here. For I equal to 0, I less than 10, I plus plus. Up to how many transactions it is doing? 10 transactions, because generate valid 10 transactions. This is the valid 10 transaction it is doing. And then see, tick UVM do with tick UVM do with what it is doing here? Create item, randomization, start item, finish item. All these items are doing with tick UVM do with request comma, so request is my handle, so create send items all are doing here, create and send a constraint request. Okay, what is that? Request dot p address equal to, based on the I we are getting the p address value, and then pw data also I plus 1, because 10 data I need to do that. So that's why pw data should be 10 locations we are writing. Set write data to index values plus 1, and then t write equal to 1. That means we are doing the write operation here. So setting 1 means we are doing the write operation. And then p stroke, all signals should be 1. That means all byte lengths are valid. Okay, if you are considering all ones means your all byte lengths are valid. And then p protect signal all are zeros means, so we are not using the protect signal here. That's why I'm assigning 0. Okay, hard coded. And then valid reads, here also 10 transactions it is doing that. And then tick UVM do with request comma, what is that? P address, pw data. So p address is high, pw data is 0 means doing the read operation. Okay, 1 means write operation. Okay, again pw w data is not getting anything here. P write is 1, 0 means it is doing the read operation. And then p stroke all are ones, and p protect signal. Then sequence is ended. Then here all 10 transactions I am doing. Okay, the sequence is generated. This is the sequencer. Sequencer is the what is that? Sequencer is the component which arbitrates in between the sequence and driver, right? So it will provide the communication between the driver and sequencer. Okay, driver and sequence. So class registration with UVM factory, and then custom constructor, and then ending the class. That is the basic thing here. And then UVM driver. What is the driver code here? So class UVM driver. Okay, class APB driver extends from UVM driver. This is the parameterized class, because I'm getting the transaction items from sequence item to driver here. So driver that converts your transactions into pin level activity, because packet level activity we are saying that that should be converted into pin level activity. And this is my class registration with UVM factory. I'm declaring the physical interface with virtual keyboard. Okay, so virtual interface handle, I'm driving that whatever the pins I'm having, that pins will be transferred to DUT through your handle. Okay, virtual interface handle, because your test bench is in dynamic nature and DUT is in static in nature. So through VAF only, virtual interface only, I'm driving my signals to DUT. Then custom constructor. What is the custom constructor here? So for every function new, say string name and your class name. After that, given component parent, that is the driver constructor, and then super dot build face UVM face, so sorry, super dot new name comma parent, because it is a component, right? Then name comma parent is there, and then end function. Similarly, build phase we are creating that. In build phase, I am trying to get that event config db. So super dot call the build phase parent. Okay, base build phase, and then if not event config db virtual app interface get this comma. So this empty space indicates that global. Okay, and then VF is my string name, and then VF is the field name. Okay, so then to get the interface from the config db. Okay, we are using the virtual interface, right? So that config db we are getting. If you are not getting the config db, we are receiving the pattern error. Okay, and then end function. So that means stop the simulation if interface is missing. Okay, and then similarly, task run phase. In run phase, what we are writing, all the signals during the initial run phase, super dot build phase, super dot run phase, that is calling the base run phase here, and I am allocating all the signals should be 0. Initially, all the signals should be 0 if during reset condition. After releasing that reset condition should be, that means I am waiting for my reset signal should be DSL. Okay, after the DSS of my reset signal, I need to drive all the signals. How I can drive the signals here? See, see, I am driving my signals here. Forever begin. So forever begin, that means continuously process your sequence, okay, up to the condition. Okay, when it is your forever loop ends, it means say vf dot p select should be, because p select we need to drag 1, and during that cycle p enable should be 0, and then maintaining the p address. That means from the request I am writing the p address signal here. Okay, so this is the p address signal, and then p data signal, pw data, and then p write, p stroke, p protect. All the signals I am driving through request to your virtual interface, and then at the rate negate pf dot p clock, I am enabling that p enable. That means, so I need to set the p enable should be 1, means I'm entering into access space. Okay, so why I need to take the another clock cycle? App at least 2 cycles are required to complete one transaction. That's why I'm taking the p enabling next clock cycle. Then waiting for p ready should be 1. Okay, so your slave response is ready, then only I'm displaying that my driver signals, all the signals. If we are not getting that display signals, then after clearing that, so we need to clear the all the signals should be 0, then my handshake signal should be done. So it will be completing that. Okay, this driver will tells you that okay, my sequence items are completed, your sequence, so you can stop the transactions. So here forever is ending, and then end the task, end the class. This is the driver code. Similarly, monitor code also same thing. Okay, so class, what is the APB monitor? Okay, class APB monitor here, and then class registration with UVM macros. Here I'm using put monitor code. Okay, analysis ports I am using that. So for that analysis port is you are sending the transaction to scoreboard through your analysis ports. Okay, so then virtual interface I am taking that. I am including that how many counts it is doing that. Monitor count equal to 0, and seeing that scene access equal to 0 also. After that, custom constructor. Custom constructor, so just a class name and parent. After that, super.new calling the parent base class, and then function void build phase. In build phase, what I am doing here, in build phase, I am getting the config db. Similarly, how we are writing the driver code, same thing here also we can write. Function void build phase, you are getting the config db. If you are not getting the config DB, you will receive the fatal error. Okay. And then task run phase, I'm creating the handle for my transaction. So this is the local transaction handle to sample your data. Whatever the data you are getting, I need to sample that. And then super dot run phase, so I'm calling the base run phase here. And again, forever begin, continuously watch your bus, and then select the passage clock we are taking. So that means every passage of the clock you need to sample your data. That means I told you that in APB signal, every rising edge of the clock we need to sample our data. So to avoid the race condition, just give the delay here. Okay. So and then if I'm taking the vf.p select, p enable, and then p ready, all scene success, all should be one means I will detect the valid APB access completion. Then so if I'm taking that select signal should be one, enable signal should be one, ready signal should be one, and then scene access should be 0. Okay, access is not there. So then I will detect that. So valid transaction is happening. Your handle is created, right? Local transaction. For that I am creating the memory here. So creating the object. After that, using create method, I am creating the new transaction here. And then whatever the VFC, what is the monitor purpose here? Whatever the signals are generating from the DET, so it will convert into packet level data. Pin level to packet level data, it is converting. See, P address, PW data, P write strobe, all signals are assigning to transaction.address. Through VAF, we are assigning that. Then based on that, I'm checking that how many counters are increasing. So just incrementing the monitor counter. So incrementing the monitor counter, then display all the values, time, address, the data, and then write, read all the signals I'm printing here. Okay. So after the printing, then here analysis port we are taking that. Okay, put monitor dot write method transaction. That means we need to do some broadcasting purpose. We are writing the write operation here. This write operation we are calling in scoreboard. Okay. After that, here not seen access, then we need to keep the access signal should be 1. That means mark access, then you can record your all the transactions. See, this is the monitor code, and I am increasing the signals, and then after that accessing signal should be 1. After waiting that, P select and P enable should be not zeros, so not ones. Then I'm completing that sampling. Okay, so that means access signal should be 0. If you have any other data, it will repeat that. Okay, again, so APB coverage from subscriber, I'm extending the coverage code. Okay, so coverage collected, that samples your all the APB transactions, what it is doing here. So class coverage, and then class registration by using event factory. After that, handle we are taking here. Okay, so APB transaction handle. So cover group name, so that is your cover group syntax. What are the signals are there? P address, PW data, PR data. That means address, data, write data, read data. I'm checking that. So for that I'm writing the bins. Bins address is the 10 addresses we are taking that, because it is 10 transactions we are taking that. 10 addresses we need to give that. And also write data are doing that 1 to 10. And read data also we are doing that 1 to 10. Then if you have any bins, so you can set that all bins to 0 here. That means if you are not covering any data, we are setting that 0 here. Then P write signal. P write signal should be either 1 or 0, right? So PowerPoint transaction dot P write. So because based on the transaction only we are getting the signals here. In sequence item we have signals, right? So for that sequence item, if we transaction we are writing, this is the handle. Okay, so handle to latest sampling transactions, whatever the transactions we are doing, we need to get this through handle only. Then write signal we are setting that. If it is writing 1, doing the write operation. It is 0 means read operation we are doing that. Then write read combinations we are checking that. Then your coverage is happening properly. And then constructor, custom constructor, coverage group, we are creating the instance here. After that, write method we are doing this. In this write method, I am sampling the coverage. So based on, because I'm not considered any clock signal. If you are taking the clock signal, then no need to write this sample signal. If you are not taking the clock signal here, then you need to write the sampling. Then only my coverage will be happening here. Okay. So then coverage is ending. After that, scoreboard. Okay. What is the scoreboard we are writing here? Class. So scoreboard, okay, it will be scoreboard extends from UVM scoreboard. And then analysis class registration we are doing that. And analysis export we are using, that is FIFO. Okay, so to monitor your transactions from the monitor to scoreboard, we are using in monitor, we are implementing the analysis codes. Here analysis export we are using. Okay, and then reference memory for reference model memory purpose. Okay, you are doing some reading operation, writing operation, we need to do some we need some reference memory. And then all count should be equal to 0 here. That means you are initiating all the signals should be, that means what are that? Total transactions count, write transactions count, read transactions count, write pass, read pass, valid read fails, and then any pass counts or fail counts. Just I'm taking the statistics. How many signals are passing, how many are failing. I want to check this. Okay. In scoreboard, we are initializing all the statistic signal should be 0. What you are taking total number of received transactions, and then write transaction, read transaction, successful writes, successful reads, and any fail count and pass count, all signals are initialized to 0. And this is the custom constructor, you know that, right? Every class we are having the custom constructor. And then build phase. In build phase, what are the signals we have taken here? FIFO and then reference memory. Okay. So for FIFO, I need to create the memory. Okay. So and then reference memory, I need to check all the conditions for each reference memory of I, and then reference memory should be initialized to 0 here. Okay. I'm initializing that in scoreboard. I'm initializing the all the reference signal should be 0. And then run phase, so UVM phase. So what we are doing here, I need to do the super dot run phase and then before dot get. So we are getting the data here and then incrementing the total count. Again, if transaction dot write, you are doing the write transaction. I need to increase my count. How many write transactions are doing? And then how the write transactions we are doing, transaction.pw data that should be assigned to your reference memory transaction.p address. That means updating your reference model memory with your write data. Okay, every time you are doing the write operation, if it is valid data, then valid write pass is incrementing and then pass count also incrementing. Then I'm displaying all the signals here. If it is not doing the write operation, then go for else condition. We are doing the read operation. So read operation, how I am doing here? This is my reference memory. Okay, that is actual data I am getting. So this is my actual data, and then transaction.pr data is my expected data. So now I am reading the so comparing the DUT read data with your reference model. Okay, so then I'm checking them. If both conditions are true, I'm getting the valid read pass. Okay, our pass count is also incrementing and displaying. If I'm getting any mismatch, read mismatch is happening, then I will get the read mismatch error. So then my count will be stopped here. Okay, so this is the reporting phase. All the reporting will be writing here. So that means all the counts we are writing here. Okay, so end write operation and read operation, all the signals we are writing. Okay, so this is the your scoreboard signal. Okay, and then agent, how the agent is represented, if we, a class APB agent extends and then UVM component. After that, in agent sequencer, driver, monitor are there. If your agent, after that custom constructor and then build phase, I need to create the memory for, so create the object for all the handles, sequencer, driver, monitor. Sequencer equal to APB sequencer type ID, create sequencer comma this, and monitor comma driver comma this, monitor comma this. Okay, in that way I want to create the agent signals here. After that connect phase, I need to connect that. What we need to connect, sequence item and driver and sequencer, I need to connect that. Okay, in connect phase UVM void phase, void connect phase, UVM phase super dot connect phase, I'm calling the base connect phase, and then driver dot sequence item port dot connect, sequencer dot sequence item port export. Okay, so just I am connecting that signals in agent. And then environment also. Environment, we are having coverage, scoreboard and agent. All the components I am creating the handles of that. After that, custom constructor, then build phase I am creating the object for each handle and the environment. Okay, so end the function. After that, build phase I am connecting. How I am connecting? So in, sorry, in connect phase I am connecting super dot connect phase agent dot monitor dot put monitor, that is the analysis port we are writing in monitor side. Okay, and connect coverage dot analysis export. Similarly, agent dot monitor put monitor connect scoreboard dot before analysis export. Okay, so this is the export signals we are writing. Okay, so based on that we are uh, broadcasting our signals. And then UVM test. Test, we need to start our sequence, right? Okay, class test extends UVM test is the UVM test is your parent class, your test extends is the parent child class, and then this is the class registration, and then APP environment, because in test we need to create the handle for the environment, because below the test environment is there. After that custom constructor and then build phase. So we have created the memory, right? So handle, right? For that we need to create the environment here. So creating the environment equal to FB environment, scope resolution, type ID, create environment comma this. Okay. In run phase, I need to start my sequence. Okay, APB sequence is the handle. Create the memory for that. Okay, create the APB sequence. In the rise and drop objection, I need to start my sequence. Sequence dot start environment dot agent dot sequencer. That means start your sequence on the environment sequencer. Okay, so ending the class. So that is my test, and then this is the assertions. What are the assertions we are writing here? Module assertion, all the signals I am writing here, and then setting that all the signals should be initialized to 0 here. Okay, so we know that P signals, P enable, all the signals we are setting, and then set any matches are there and then mismatches are there, all we are setting that. See, property P setup to access phase. So setup to access phase, how we are moving that? Setup phase, P select signal should be 1 and P enable should be 0. Or that means this is true, and then go for non-overlapping. The next cycle we are getting the transaction. Then next cycle P select and P enable should be 1. That is the setup to access phase. And then access to ready. Access ready phase means, so access phase P select and P enable should be 1 and ready signal should be 1. In the next cycle we are writing the same cycle, we are checking that P ready signal should be 1 or not. Okay, and then So asset property, so what is that? Set up to access, so we are assetting that property, so this will automatically get that, and then asset the property, we are checking that access fail or not. Similarly, we are writing that setup attempt, how many attempts are there, how many mismatches are there. See, select signal and enable signal should be 1, and non select signal should be 1, and reset signal should be 1, and then enable signal should not be 0. Okay, so enable signal should not be 1, then it is should be 0. Then it detects that setup phase when reset is inactive. Okay, so is that happening or not? That means reset is active, means you are detecting your reset is inactive. Okay, if it is 1, okay, p select and p enable signal should be 1, then you are detecting the access phase during reset is inactive. Okay, so I need to check that and display the assertions. After that, top module. In the top module, what we are writing: clock generation, clock signal initialization and reset signal initialization. After that, generating the clock. Okay, for every 5 clocks, so 5 nanoseconds. So we are generating the clock. So that means every 5 clock cycles, I am toggling my clock signal. So total time period is 10 nanoseconds, because this is the delay. 2 into delay, we will get the total time period. Initial begin p reset n equal to 0, that is during the reset condition, and we are releasing the reset condition. After that, releasing the reset condition, all the signals should be initialized to 0. Okay, all the signals should be initialized to 0. What we need to write in top module still, I want to instantiate my um, what it called, I want to instantiate my DUT signals in top, and then assertion signals in my top. Okay, both are signals are same, but just assertion we need to take, and then top DUT I need to consider it. Okay, after the instantiation, then initial begin config db I need to set here in top module. After that, I want to run my test. Okay, clear? So then you can run this code. Hmm. So one test is done. Okay, so all are one here. See, access setup to access phase, attempts 20 matches, and then all are 20 matches are getting, and fails are 0. And then access to ready phase, attempts 20, matches 20, fails 0. Okay, so now you can check that total transactions 20 doing, and the write transaction 10 and read transactions are 10. Write valid pass are 10, read valid are pass 10. So read fail is 0, pass count is 20, fail count is 0. Okay, so this is the test summary. So in this, what we are doing, so 10 transactions we are writing, right? See, at the time cycle address 0, write 1, W data 1, read data 0, P ready is 1, and slave error should be 0. Okay, after that time monitor 1, so this is the driver signal, and you are monitoring that address signal should be 0, write 1, write data 1, read data 0, and then PR data 1, slave error is 1. Then what is your scoreboard? Your scoreboard valid write should be passed, and address equal to 0, data equal to 1. Similarly, all the signals here, monitor, driver we are driving, address 2, data 2, and then address 1, same address, and then data 2, same address 2, and then data right signal 1, and then data 3. So in that way, I am checking all the 10 transactions. Okay, so 10 transactions, 10 monitors I am writing here. And similarly, 10 read write operations. Clear?